Alrighty guys, so in today's lecture we are actually going to be combining the concentration calculations that we've learned about recently with stoichiometry. But before we do, let's just do a quick review of molarity calculations. So this is review, so if you feel confident doing this, feel free to pause the video and try it on your own. Okay, so the question is asking us how many moles of N2 are in 100 milliliters of a 0.5 molarity N2 solution. So here we are looking for moles. Okay, so we're going to use this equation right here, the molarity formula. So I'm just going to copy that down. Capital M, molarity equals moles over liters. Okay, so we know we're looking for moles, so we're going to be looking for this guy right here, the top of the fraction. Okay, for the capital M molarity, we know that it's 0.5 molarity, so I'm just going to plug in 0.5 molarity equals, I'm looking for moles, so I don't have that yet, so I'm just going to write that down. And then for liters, it says that we have 100 milliliters, so what we're going to have to do is we're going to have to convert this into liters. So we're going to set up a fraction. We're going to put milliliters on the bottom so we can cancel them out, and we put liters on top since that's what we're looking for. We're going to use this equation right here because it has liters and milliliters in it. So that's what we're going to be using for this equation. The number next to liters is 1, and the number next to milliliters is 1,000. So these are going to cancel out. And so for our calculations, we just need to top divided by bottom. So 100 divided by 1,000, that should give us 0.1 liters. And this is what we're going to plug in on the bottom of the fraction right here. So 0.1 liters. Alright, so here we just need to calculate this out. So what I'm going to do is I'm going to multiply both sides by 0.1 liters. That way these can cancel out. That means I have to multiply this side by 0.1 liters. That means moles is going to be 0.5 molarity times 0.1 liters. Okay, so if you put this in your calculator, 0.5 times 0.1, that should give you 0.05 moles. Okay, and it'll be moles of N2. Alright, so this should have been pretty simple. All we're doing is using this formula. Now, we said before that all these calculations, what it tells us is that, hey, if I have a container, right, and we're just going to use the numbers that we have with our solution, and if the amount of solution right here, the amount of solution that we have is 100 milliliters, okay, the concentration of the solution is 0.5 molarity, okay, so we have this right here. Okay, based on our calculations, what that tells us is that, hey, there's going to be N2 molecules inside of this solution. And how many molecules do we have? We have 0.05 moles. Okay, and that's the answer that we found here. So this is basically what it looks like in real life. We have a container, right, and we have 100 milliliters of solution in there. We have 0.5 molarity. That's the concentration, how, I guess, strong it is, how much of the compound we have in there, and the amount that we have is 0.05 moles. Now, what we're going to be doing is we're going to be learning about how we can do stoichiometry with this. So when we have, so unfortunately we can't have labs because of COVID right now, but typically what we would do is we would start mixing these chemicals together. But a lot of times you can't just put two chemicals together and expect it to react. You're going to need to have the compounds in solution. Okay, so what we would do is we would add a different chemical in here, right? And then that chemical, let's just say the chemical is red, okay? Okay, and then the red and the black chemicals would react in here. And so they're combining, they're reacting together, they're breaking apart. And so what we're going to be doing today with stoichiometry is seeing how much of the new compounds we'll make when we react compounds together in solution. Okay, so that's what we are going to be working on or learning about today. Okay, so let's learn how to do that. Okay, so before we get started, I want you guys to copy these steps down. So whenever we have a solution stoichiometry problem, like the ones we're going to be doing today, and we're going to be doing for the rest of the unit, you're going to want to follow 4 steps. Now, 3 of the steps are exactly the same as the ones that we learned about in just regular stoichiometry. The first step is we need a balance. That's the same. We're going to identify the given and the end. That's also the same. But the new step is going to be this one right here. We're going to use molarity to find the moles of the given. So if you guys remember in our stoichiometry problems, I told you guys to remember that phrase, gamumaga, right? Grams, moles, moles, grams. So the top of the fraction will have grams, and then the second fraction will have moles, and then we'll have moles, and then we'll have grams. If you guys remember, this is our process for stoichiometry. We have gamumaga. Okay, but when we do stoichiometry with solutions, we're not going to be using gamumaga anymore. Instead, what we're going to be doing is we're going to be in step 3. What we're going to do is we're going to use the molarity formula, and then we're going to find moles. So we're going to find moles. And once we find moles, we're going to set up 2 fractions, and then we're going to find moles of the other chemical, and then we're going to turn it into grams of the other chemical. So I know that in the previous unit we did gamumaga, but in this unit we're just going to do mumaga. Okay, mumaga. Okay, so this was the last unit for just regular stoichiometry, so the last unit. But for this unit, we're going to just do mumaga. Okay, and we're going to be using, I guess this would be the step that replaces this part right here. So we're going to be replacing this, just the grams to moles, with molarity to moles. Okay? All right, so hopefully you guys got that copied down. If you're not done copying it down yet, make sure you pause the video and get it down, because these are the steps we're going to be following as we solve the problems below. Okay? All right, so let's move on, and we're going to do 2 examples together before I let you guys go and work on your assignment. Okay, so we said step 1. Step 1 is going to be balance. Okay, so step 1, we're going to balance. So what we're going to do is we're going to balance this chemical equation right here. Okay, so we are going to do the chart that we did last time. I know it's been a while since we did balancing, but we're going to count how many of each element we have for on each side of the equation, excuse me. So we know that the elements in this equation are nitrogen and hydrogen. Okay, lucky for us, it's pretty simple. And then we're going to make a table, and then this part is going to represent the left side of the equation. So right here, the reactant side, and then the right side is going to represent the product side, the right side. Okay. Okay, so what we're going to do is we're going to count. So how many nitrogens do I have on the left side? I have N2, so there's 2 of them. How many hydrogens do I have? I have 2. And then we're going to go to the product side. How many nitrogens do I have? It's N, and there's no number, so it's going to be 1. And then hydrogen, there's a 3, so it's going to be 3. Okay, so it looks like the nitrogens are not balanced. And what we're going to want to do is we're going to want to add to the side that doesn't have, or that has fewer. So since the product side, the right side has fewer, we're going to add N, but we can't just add an N by itself. We have to add the whole molecule. So if we add the whole molecule, that means I have 2 N's now, so it's 2. And then I have 3, and then we have 6 hydrogens. Okay, so the nitrogens are balanced, but the hydrogens are not balanced. So what I'm going to do is I'm going to add a H2 right here. That's going to take me from 2 to 4. And then in order to get to balance it out, I'm going to have to add a third one to get to 6. Okay, so what that means is we can write our coefficients. So for N2, we don't need to put a number in the front because there's only 1 of them. For H2, we have 1, and then the 2 that we added, so we have 3 total. So the number I'm going to put in the front is 3. And then for NH3, there's 2 of them, so I'm going to write 2. Okay? So that's going to be our balancing. So we've balanced the chemical equation. Okay, so now what we have to do is we're going to go to step 2. Step 2, we're going to identify our given and our end. Okay, so step 2, we're going to identify the given and the end. I'm just going to write GE, okay, given and end. So let's read the problem. So the problem asks us, suppose that 100 milliliters of 0.5 molarity N2 solution reacts with excess H2. How many grams of NH3 will be produced? Okay, so what that means is we need to figure out what we're trying to find and what we start off with. So usually the end is easier to find because it usually comes after how many or how much. So here it's asking how many grams of NH3. That means we're looking for NH3. So this is going to be our end. Okay, we're going to be looking for grams of NH3. We're going to end with this one. Okay? So our end is grams of NH3. Okay, our starting number is usually the one that we have numbers for or is not excess. So here we have two options. We could either start with N2 or H2, but if you guys remember, we have excess H2. If we have excess, that means we have so much we don't need to worry about it for our calculations. So that means we're not going to be really considering H2 in our calculations, which naturally means that we're going to start with N2. So this is going to be our given. And we also know that it's our given because it's the one that we have all these numbers for. We have 100 milliliters and we have 0.5 molarity N2. Okay? So we have our given and our end. So that's our step 2. Okay? Let's move on to step 3. So step 3 is where we're going to be using the molarity formula. So we're going to go from molarity to moles. Okay? Alright, so for this step right here, we're going to have to use the molarity formula, and we know that the molarity formula is moles over liters. Okay, so let's use the numbers that we have. So if we take a look at this, it says that we have 100 milliliters and we have 0.5 molarity. So for the capital M, I'm just going to put in 0.5 molarity equals, I'm going to look for moles, right? I want to turn it into moles, so I'm going to put moles on top. On the bottom, I need liters. I have 100 milliliters. And so if I want to turn 100 milliliters into liters, I need to do dimensional analysis. This part should look a little familiar. We just did it for our warm-up problem. But 1,000 milliliters is 1 liter. Milliliters cancels out, and that should give us 0.1 liters. Okay, so on the bottom, we're going to put 0.1 liters. So I don't know if you guys noticed, but this is basically the same problem that we did for the warm-up. So if you want to go through the calculations again, you can just to make sure. But our answer here is the moles is going to be 0.05 moles of N2. Okay, so that's going to be our step 3. Step 3, what we did was we took the molarity formula and all this information about N2, and then we turned it into moles. Okay. All right, now we're going to move on to the final step, step 4. Step 4 is basically where we use dimensional analysis, stoichiometry, okay? So if you guys remember, we're going to do mumaga, okay? Mumaga. Not gamumaga. Gamumaga is for regular stoichiometry. For solution stoichiometry, we just use mumaga. All right, so let's set up the problem. So we're just going to use mumaga. So since we know that we start with M, we're going to put moles. Okay, we're going to set up a fraction. Okay, since it's m, so the second sound is m, so it's moles. And then the last one is g, so we know that we're going to end with grams. Okay, so if you just remember this weird sound, mumaga, you'll set up your fraction correctly every single time. Okay, so if you guys remember, the last two fractions are always going to be about the same chemical. Okay, and it's always going to be the end chemical, okay? So we want to end with grams of NH3, so I'm going to put NH3 right here. That means that the second fraction is going to be about NH3, okay? Which means that our starting number for this problem is going to be this right here, moles of N2. So we're just going to bring this down, and that's going to be our starting number. So our starting number for this problem, or for this dimensional analysis, is going to be 0.05 moles of N2. Okay, since I have moles of N2, I don't want that though. I want to find grams of NH3, so I'm going to put moles of N2 on the bottom. Okay, if you guys notice, there's moles and moles on the same fraction. If there's moles and moles on the same fraction, that means you're going to get the numbers from the chemical equation that you just balanced. Okay, so if you take a look at the chemical equation, what number is in front of N2? There's no number. If there's no number, that means it's 1. So I'm going to put a 1 on the bottom of the fraction because that's where N2 is. And then for the top of the fraction, NH3, what number's in front of NH3? We got a 2. So we're going to put a 2 on the top, for moles of NH3. And then we can cancel out the moles of N2, and then we can move on. We have moles of NH3 on top, but I want to turn to grams, so I'm going to put what I'm trying to get rid of on the bottom. I'm going to put moles of NH3 on the bottom. Okay, if you guys notice, there's grams and moles on the same fraction. If there's grams and moles on the same fraction, you're going to get your numbers from the molar mass. So what we're going to have to do is we're going to have to find the molar mass of NH3. Okay, so if you guys go on your periodic table, let me just erase this part real quick. If you guys go on your periodic table, you're going to look up the elements that make up NH3. So nitrogen, N. You're going to notice that the molar mass, the number on the bottom of the box, is 14 grams per mole. And then for H, it's going to be 1 gram per mole. But there's going to be 3 of them, right? So we've got to multiply that by 3. Okay, so if you put all those together, we have nitrogen, which is 14. We have hydrogen, that's 1, but since there's 3 of them, 1 times 3 is 3. So 14 plus 3, that means that NH3 is 17 grams per mole. Okay, the molar mass of NH3 is 17 grams per mole, and that's what we're going to use for this final fraction. So the number next to grams is 17, so we're going to put 17 on top. The number next to moles is 1, so we're going to put a 1 on the bottom. And then the moles of NH3 will cancel out. Okay, from there, you guys need to just calculate it out. So I'll give you guys a second to try that on your own, and then after that, I'll show you guys just the final answer just to make sure you got it correct. So take a second to pause the video so you can solve it out on your own. But ready or not, we're going to go right now. I'm going to assume you paused the video. Okay, so we're just going to do top divided by bottom. So on the top, we have 0.05, so 0.05, and then we have a 2 on top, so we're going to multiply that by 2. We can ignore the 1 on the bottom, and then after that, we just need to multiply that by 17. And for our final answer, we are going to get 1.7. So we have 1.7, and our units is grams of NH3, and we want to make sure this is what the question was asking for. So if we go back up here, you're going to notice, hey, you were looking for grams of NH3. Okay? Okay, so what does this mean? So if we kind of visualize it, I know unfortunately we're not doing labs right now because of COVID. And if you're watching this after COVID, then consider yourself blessed because you're actually able to do this in real life. So basically, if we have this solution right here, okay, so let's assume that we have this solution of N2, okay, and the molarity is 0.5 molarity N2, okay, so this is where we got the number. Okay, and if the size of our solution is 100 milliliters, okay, that means we're gonna have some N2. We're gonna have a bunch of N2 molecules in here, right? And how much do we have? How many N2 molecules do we have? That means we have 0.05 moles of N2, and we got that number right here. Okay. So if we combine 0.05 moles of N2 with excess H2, so if we let's just say I'll symbolize it with black. So if we put, actually no, I did N2 as black. I'll symbolize it as blue. Okay. So if we put excess H2 in here, okay, so if we put H2, what that means is that the N2, the black dots, and the H2, the blue dots, they're going to react together, right? They're going to combine, they're going to break apart, whatever, and they're going to react. And what's going to happen is over time, if we assume that all of the N2 reacts with the H2, that means we're going to have, inside of this container, we're going to have NH3. And how much NH3 did we make? We made 1.7 grams of NH3. Okay, so it's not only NH3 in here because we got the solvent that we used to make the solution, and if it's excess, that means we have some H2 in here as well. But the point is, we make NH3 when you combine those two compounds, and the amount of NH3 we can make is 1.7 grams of NH3. Okay? So today, solution stoichiometry isn't really anything new. It's stuff you've been doing. It's just solutions, so like molarity and stoichiometry. We're just putting it together. Okay? So I'm going to try one more problem with you guys just so you guys can get a little more help. But if you guys think you guys can try this on your own, I really encourage you guys to pause the video and try it just to see if you guys can get it before you guys do the assignment. It's very helpful. Okay, so let's go through the steps. The first step, we are going to balance. So step 1, let's balance. Okay, the elements that we have are Ag, we have H, and we have Cl, and we're going to make our table. On the left side, we have 1 Ag, 1 H, 1 Cl. On the right side, we have 1 Ag, we have 2 Cls, and we have 2 H's. Okay, we got to balance it out. We have balance, our Ags are balanced, so we're going to start with the H and the Cl. So you want to add to the side that has less. So H and Cl have, H and Cl, there's less on the left side, the reactant side. So we're going to have to add HCl to the left side. Lucky for us, that means we have 2 H's and 2 Cl's, so they're balanced out. So what that means is the number that goes in front of HCl is the number 2. And that's all we have to do for balancing because we didn't touch anything else. So pretty easy balancing problem. Okay, now what we're going to do is we're going to go on to step 2. We're going to figure out our given and our end. So step 2. So let's read the problem. We have 100 milliliters of a 0.075 molarity Ag solution. Okay, so we have all these numbers for Ag. There's no way they're going to give us all this information and not make us use it. So this is going to be our given. Okay, our given is Ag. And then we can double check that by looking for the excess. The excess is HCl. So that means we have so much HCl, we don't need to worry about it for our calculation. So we're going to be ignoring HCl completely. And then it's asking us how many grams of H2 will be produced. So that means our end, what we're looking for in this problem, is grams of H2. Okay, so we did step 2 just by reading the problem. We have Ag as our starting numbers. We have a lot of HCl, so we're not going to use it. And then for grams of H2 is going to be our ending. With respect to AgCl2, there are going to be problems later on where you need to find both products. Like if you guys remember from our previous assignments in the last unit, there are times you're going to have to find both products or all products. So for this problem, we're not going to do that. We'll do that probably next time, but just we can ignore the AgCl for now. Just find what the question is asking you to find. Okay, step 3, you want to use the molarity formula. So molarity equals moles over liters to find the moles of your solute, the thing that's dissolved. Okay, so let's just plug in the numbers. Okay, so the number for capital M for molarity is going to be 0.075. So I'm going to plug in 0.075 molarity equals, I'm going to look for moles. So I'll put moles on the top. And then for liters, excuse me, for liters, my voice is cracked. For liters, we're going to have to turn milliliters into liters. So what we're going to do is we're going to use dimensional analysis again. We have 100 milliliters, set up a fraction, put milliliters on the bottom, liters on top. We know just from our previous examples with this that 1,000 milliliters equals 1 liter. So we put a 1 on the top, 1,000 on the bottom. The milliliters will cancel out, and we do 100 divided by 1,000. That'll give us 0.1 liters. So that means we're going to put 0.1 liters on the bottom. Alrighty. So what we have to do is we just need to solve for it. So the best way to do that is just multiply both sides by 0.1. So that means our moles, oops, wrong color. So for our moles, we're going to have to multiply 0.075 molarity by 0.1 liters. Okay, and then if you guys do that, you'll get a final answer of 0.0075 moles. Okay, so the moles of Ag that we have are 0.075. Okay. All right, so that's step 3. Step 3 is pretty simple. We're just doing the regular molarity calculations we learned the last 2 class periods. Okay, step 4, we're going to do our stoichiometry, our dimensional analysis. So if you guys remember, the way that we're going to do it for solution stoich is just mumaga. So before we even get started, I'm going to start setting up my fraction. Our starting number is going to be moles. I'm going to set up a fraction. The second one is going to be moles because it's m, so moles, moles. And then it's going to be mmg, so we're going to put grams. And again, if you guys remember, the last two fractions, the tops are going to be about the end chemical. Okay, we're looking for H2, so I can just plug in that it's going to be about H2 without even looking at anything else. Okay, we're going to take our answer from step 3 and use that for our starting number. So we have moles of Ag, and then we're going to start with 0.0075. Okay, we want to get rid of moles of Ag, so I'm going to put moles of Ag on the bottom. Since it's moles and moles on the same fraction, that means our number is going to come from the chemical equation that we balanced. Okay, so we just look for these chemicals. What number is in front of H2? There's no number, so that means it's 1. So we're going to put a 1 on the top. What number is in front of Ag? There's no number, so it's just going to be 1. And then the moles of Ag are going to cancel out. Okay, so for moles of H2, we want to get rid of moles of H2. So we're going to put it on the bottom. Since we have grams and moles on the same fraction, we're going to use the molar mass of H2. So if you go on your periodic table and you look for H is just 1 gram per mole. So H2 is 2 H's, so it's going to be 2 grams per mole. So the molar mass of H2 is going to be 2 grams per mole. So I'm going to put a 2 next to grams, 1 next to moles, and I'm going to let the moles cancel out. Okay, from there, we can just solve it out. So we're going to go on our calculator and just plug in the numbers that we have, top divided by bottom. So our starting number is 0.0075. The first fraction, if we multiply by 1 and then divide by 1, it's the same thing, so we can ignore it. That means we only need to do calculations for the last fraction, and we're just going to multiply the top, which is 2, and we'll get 0.015. Okay, so that means our final answer for this problem is 0.015 grams of H2, and that's going to be our final answer. Okay, so hopefully that was helpful, guys. I am on the Zoom call, so let me know if you guys have any questions, but that is how you do stoichiometry with different solutions. Good luck on the assignment, guys, and let me know if you guys have any questions.